Good morning, students. Welcome back to your online mathematics class. So today we will study multiplicative inverse of a complex number. So in previous video I had explained you carefully what is modulus of a complex number, what is conjugate of a complex number. Now we will study multiplicative inverse of a complex number. Now see, suppose let us take any complex number. Z is equal to a plus ib. Are you following, students? Z is equal to a plus ib. Now if I write Z, this inverse, okay, this can be written as 1 upon Z, okay, Z inverse, okay, multiplicative inverse, okay, of a complex number, Z inverse. That is why it is multiplicative inverse. So Z inverse I can write as 1 upon Z, which is equal to 1 upon a plus ib. Clear, students? Till here no problem. Now if this 1 upon a plus ib, if I multiply and divide by the conjugate, so what is conjugate of a complex number, students? I explained you. So the sign of the imaginary part of a complex number will be changed. So a minus ib upon a minus ib, right? I am multiplying and dividing by the conjugate of this complex number. So this is equal to a minus ib upon a plus ib into a minus ib, right, students? So numerator will be same, a minus ib upon, now this is a plus b into a minus b. So a plus b into a minus b is a square minus b square. So I'm writing here a plus b into a minus b is equal to a square minus b square. Okay, this we studied identity in our junior classes. A plus b into a minus b is a square minus b square. So this will be a square. I can write it directly, a square minus b square. So what is the value? Ib minus ib whole square, which is equal to a minus ib upon a square minus, so I square is minus 1 and b square, right, which is equal to a minus ib upon a square plus b square, right, students? Can you see this carefully? Minus minus will become plus. Just see this. Are you following? A minus ib upon a square plus b square. Is it clear to you, students? So nothing difficult here. Now if you see this a minus ib, this is conjugate of a complex number, okay. If z is equal to this, so what is z bar? So z bar we studied is equal to we will change the sign of imaginary part. So this is equal to z bar upon, now what is mod z? So we studied modulus of z, okay, is a square plus b square under root. We studied in previous videos. I had explained all this. Now if I take mod z whole square, so mod z whole square will be what? A square plus b square square root, okay. So I am taking square on both sides, so the square root will be vanished now. So we will get a square plus b square. So I can write here modulus z, okay, whole square is a square plus b square. So this I can write as modulus z whole square. So 1 upon z is equal to conjugate of z upon modulus z whole square. Okay, students, are you following? So this relation is very important. 1 upon z is equal to conjugate of z upon mod z whole square. I can rewrite this as, okay, 1 minute, just I can rewrite this as, if I multiply this, I will get z into z bar is equal to mod z whole square. This is very important, students. Okay, are you following, students? So z is equal to, I'll repeat from the beginning, okay. I'll change the markering so it will be easy to differentiate. Okay, so now understand carefully. I'm repeating again. We are studying multiplicative inverse of a complex number. Okay, let the complex number be z is equal to a plus ib. So what is conjugate of z? A minus ib. Studied in previous video, I had explained all this, students. What is modulus of z? Square of the real part plus square of the imaginary part and square root. Clear? So if I take mod z square, if I do squaring on both sides, this square root will be managed. Okay, so what will be left? A square plus b square. Okay, now come here. Multiplicative inverse of a complex number. Okay, multiplicative inverse of a complex number. So this z raised to the power minus 1 I can rewrite as 1 upon z, which is equal to 1 upon a plus ib. So 1 upon a plus ib, if I multiply and divide by the conjugate of this. So what is conjugate? The sign of imaginary part is changed, a minus ib, and divided by a minus ib. So what will I get? Multiply this numerator. Anything multiplied by 1 is 1. So a minus ib, a plus ib into a minus ib, right? So what is the identity we know studied in previous junior class students? A plus b into a minus b is a square minus b square. Followed? So a plus ib into a minus ib will give me a square minus of b square. So this whole is b, ib. So I square we know is minus 1. Okay, see I'm writing here I square is equal to minus 1 imaginary number we studied, and b square is equal to b square. So a square minus 1 into b square. Are you following? This will be minus b square and this minus. So minus minus will become plus. So what are we getting? A minus ib upon a square plus b square, which is equal to, now this is conjugate of a complex number. So conjugate of a complex number divided by the square of the modulus. So we can say that multiplicative inverse of a complex number, this 1 upon z, this 1 upon z is equal to conjugate of a complex number, okay, divided by the square of the modulus. Okay, now see this relation, 1 upon z is equal to conjugate z upon square of the modulus. So I have given you the derivation for this. Okay, so you should know. Okay, this is important, you should know. That is why I have explained to this. And from this relation, okay, we are getting z into z bar is equal to mod z square. Very important, students. Okay, so this means the product of a complex number with its conjugate is equal to the square, okay, is equal to the square of the modulus of a complex number. Okay, I will prove this also. You can also cross check if you take any complex number and multiply by its conjugate. Alright, so value what you will get is square of the modulus of a complex number. Okay, I will prove this also. So in the forthcoming video, I'll start with the questions and we will use the same concept. Okay, we will be using what I had explained in the beginning. Okay, we will be using modulus of a complex number, mod of a complex number. We would be using conjugate of a complex number. We would be using multiplicative inverse of a complex number. So keep this in mind, students. It is very important. Okay, so be good and study well. Okay, students, now I'm starting with the question number 11. Okay, question number 11. Okay, and it says that you find multiplicative inverse, okay, of a complex number. Okay, multiplicative inverse of a complex number. The complex number is 4 minus 3i. So z is equal to 4 minus 3i. So 1 upon z is equal to 1 upon 4 minus 3i, right, which is equal to 1 upon 4 minus 3i. So what did I tell you, students? If I multiply and divide by the conjugate, so now I'll take directly, so conjugate will be 4 plus 3i upon 4 plus 3i. Why? Because the sign of the imaginary part is changed in conjugate. So we will be getting now 4 plus 3i upon 4 minus 3i into 4 plus 3i. So this is again a plus b into a minus b. Okay, so I'll write here a plus b into a minus b is equal to a square minus b square. So 4 plus 3i into 4 minus 3i is equal to, what is the value of a? 4 square minus, okay, what is the value of b? 3i, alright, 3i whole square. So this will give me 4 square is 16 minus 3 square 9, I square is minus 1, right? So this will be 16 plus 9, which is equal to 25. So I will write this value here, which is equal to 4 plus 3i upon 25. Okay, so I can rewrite this as 4 upon 25 plus 3 upon 25i. Are you following, students? So 4 upon 25 plus 3 upon 25i is the multiplicative inverse of this complex number. Okay, I am writing multiplicative inverse of 4 minus 3i is 4 upon 25 plus 3 upon 25i. This calculation I have done here, students. Okay, 4 minus 3i into 4 plus 3i. Okay, you can see this calculation. Okay, let me change the markering so it will be easy for you. See this. Okay, 4 plus 3i into 4. Okay, so calculation I have done here. Okay, so 3i square means 3 square 9. I square is what? I square is equal to minus 1. Imaginary number, students, I had explained you. Alright, so minus 9. Minus will become plus, so 16 plus 9, 25. So 4 upon 25 plus 3 upon 25 I. Are you following, students? So this way you will calculate multiplicative inverse of a complex number. Alright, students? Okay, this is if you multiply and divide by the conjugate. Okay, so what is the conjugate of z? Conjugate of z means what? You will change the sign of the imaginary number. Okay, so now directly you can solve. I explained very deeply in the previous questions. The concept has been explained in detail, students. So now you can directly solve them. So in this way you will complete these questions in which you have to find multiplicative inverse. Okay, so study well and be good students.